Good morning, everyone. Nice to see you all, and welcome to the launch of the Sustain 4th Early Career Research Call. So I'm Sarah Roberts, Project Manager, and for your information, we'll be sending out the slide pack at the end of this meeting. Next slide, please. So a quick look at the agenda. We'll have an introduction from our Director, Cameron, in a moment. For the scope of the call, we have our scientific leads talking for just 5 minutes each on their area of expertise. We will go through who they are later on. I will cover the application process, and then we have some of our previous successful applicants who have done very well since completing their ECR award to talk about their experience. And then we'll have the Q&A session for the opportunity for you to ask questions on the whole thing, from what the scientific leads have said and what our ECR mentors have said as well. Next slide. So we have other people on the call that will be talking about their subject matter later on here, so we can go to the next slide now. And here we have our scientific leads. We have Zushu, high temperature reactions and kinetics, Arnold, computational and modeling, Mark, characterization and monitoring, and Claire, metallurgical rules. And then our ECR champions on the right. So we have Frank, Peng, and Stephen, who'll be talking later to give some of their very well-earned advice. Slide 5. So the next time I'll hand you over to Cameron to talk through everything to do with Sustain.
Hi, everyone. I'm coming through loud and clear, I assume. So I think before, obviously, we introduced the call, there might be some people who are new to Sustain as a program. So I just wanted to say a couple of things about not just what the program is, but kind of our culture, how we operate, and why the ECR call or the ECR calls that we have run and this ECR call that we are running are we're really proud of and are really sort of core to what we're trying to achieve with the hub. But what is the hub first? So Sustain stands for Strategic University Steel Technology and Innovation Network. And I think the network part of that is actually really important. So yes, we have a research program, and it's very important to deliver high quality research outputs that have impact on the steel industry across the UK. But the network aspect is also incredibly important to us. So it's a bit of a busy slide, this, but I just wanted to sort of talk on a couple of aspects of it. So the hub is based at Swansea University, but we had initial partners at Warwick, Sheffield, to start the programme. But that hasn't limited us in terms of engaging with a whole range of new partners in other universities, which are indicated over here. And to that end, and with that network ethos in mind, we run lots of events, and anybody really who's been in receipt of any of the Sustain funding is often invited along to present their work at those sorts of events and meet a wider range of people. We're obviously very strongly supported by the UK steel industry and the major steel producers in the UK, and the idea is that we're guided by 2 grand challenges, which I'll explain in a little bit more detail in just a minute. And when we work with the university partners and some of these partners from the scale up and innovation side, so where we're looking to try and turn some of the ideas into money rather than money into ideas, if you think that's what we're doing at the research level. And then the whole principle of the program is and was that we then return information back to the steelmakers to allow them to make informed investment. And you will see that if you just casually glance at the news, that there is a lot of investment now going into the steel sector, and we're an important part of that. So the ECR call is, of course, an opportunity to join this network and collaborate with this wider range of partners and get more exposure to and contacts within the steelmaking community in the UK, both from an academic and an industrial perspective. Next slide, please. So I think I've covered this already, but I mean, a whole series of events and different networks, and also there's some pictures here which indicate access to facilities as well. So that's something where if you've got some part of your idea from your project that you want to put forward that you maybe don't have all of the facilities to use, then you're welcome to talk to us about how you can have access to the facilities that exist within the hub to help you complete your research. Can you move on, please? We have ambitions and objectives and underpinning all of that, values. And I don't really have the time to talk about all of those things, but I did want to dwell just briefly on the values that we have within Sustain, because they're an important part of what motivates us and where we spend our money, to be perfectly honest. So we're a very open and welcoming community, and collaboration for success and open innovation are sort of key pillars of what we do. Obviously, we want to deliver steelmaking that's fit for a healthy and resilient nation, and resilience has probably never been more important than it is right now. We have a strong focus on trying to think about what this all means for the customers and how we integrate the supply chains across the UK. But the really important part for us, and something that I take incredibly seriously, is our commitment to responsible innovation and career development. And the ECR calls that we run, and this call that we're running now, is really a key pillar of being able to try and deliver that as we support people to develop their careers and build links within the steelmaking community for mutual benefit. So we will benefit from having your new ideas, and you will benefit from all of that experience that you'll gain in the process. So can we move on, please? So we have these two grand challenges. The first one is in carbon neutral iron and steelmaking. So this provides a context for the research and gives you an idea of the sorts of areas that we want to focus on. So we need to provide a decarbonised footprint for production within the UK. And then the next slide. The second grand challenge then is smart steel processing. And this is really about, obviously, once you've established a sustainable base for production within the UK, there's no point in you're not going to remain competitive unless you've got, you know, novel and extremely globally competitive production methods and technologies that support those production methods to produce the material on that sustainable footprint. So it's this twin-pronged approach that we're interested in developing. And these are the two grand challenges, these are the two guiding principles, and we've got some examples of the themes that we have that sit under those two different areas. And as Sarah mentioned, if you're not pulling all of this out of this presentation straight away and remembering it all, don't worry, because we'll be circulating the slides. To provide a little bit more information on this, and I don't want you again to absorb all of the information on this slide immediately, but just to give you an idea of the sorts of tasks that sit under the themes. So in emissions management, utilisation under carbon neutral iron and steelmaking, we're looking at how we can utilise CO2 to generate new products. So much more focus on utilisation than on storage. And then looking at resource efficiency, and particularly how we decarbonise the iron making process. From a data-driven perspective, we're looking at advanced scrap sortation processes and the way that we can tag and process data that comes from steel making. And then in the smart steel processing, we have a strong focus and some strong work on sensors, which I think you'll hear about a bit later on, and particularly in designing alloys that are more sustainable from a steel making perspective as well. So this just gives you a flavour of some of the things that we're already doing, and that's important to consider in terms of both opportunities to collaborate and also what we'll be doing in the future. And this is all underpinned by measurement technologies through life cycle analysis, and that's the task there at the bottom. Okay, so we're moving on. So why is it important to apply? Well, for us in the steelmaking sector, we're simultaneously, I think it's obvious, investing, but also going through an extremely tough time and developing a critical mass that's going to support what will be certainly a vibrant future for steelmaking in the UK in the future, yeah. Then we have to really have that strong base of knowledge, expertise, and a strong skill base, and just the sheer number of people who are both engaged with the sector, but also, you know, appropriately skilled and have the appropriate experience to be able to support the sector into the future. And we want to support industrial engagement. So the opportunity through the call is also really important in terms of us being able to link you with different people throughout the steelmaking supply chain to try and support the development of your ideas and your proposals. You will develop a track record and gain experience whether you're funded through this process or not. So this is a a really supportive environment, as you're going to see as we move along, and those who have been through this process before will testify to, which really gives you an experience in terms of applying for funding and gaining your own research independence, irrespective of whether you're funded or not. Obviously, there are benefits to being funded over not being funded, but even those who are unsuccessful, we're really looking to try and develop the skills, the research skills within those people as well. So there's lots of reasons to apply. I've mentioned before about the access to facilities, and one of the strongest things really is that those of us who've been working in the sector a long time obviously have an implicit understanding of the challenges and all that sort of stuff, but we're probably also necessarily fixated on our own history in the sector and the way that we think about it, and we're open to be challenged with new and disruptive ideas that come from people who might only be recently engaging with a sector or at the early stages of their career. So this is really an opportunity for you to put forward your ideas and lead your own research in an area that could totally disrupt the way that some of the older heads in the field might be thinking about it. So, next slide, please. So there's a whole list here. Again, I'm not going to read them all out of previously funded ECRs. I guess the main thing to look at though here is the range of different projects. So we're quite, as long as things fit within the scope of our scientific challenges, which are driven by our grand challenges from a scientific perspective. Then we're relatively open to a wide range of projects from different areas. So we've got everything here from sensors to the distribution of copper, which could be a key contaminant in future circular supply chains, the development of novel nuclear steels, methods of developing new sustainability models. I'm just picking out a few at random. Next slide. Looking at opportunities to measure texture using big data approaches to model steel making processes, and looking at new opportunities for DRI or direct reduced iron as well. So a whole range of things. So don't be limited by your idea as long as it fits within the scope of our scientific challenges and addresses one of our grand challenges. Next slide, please. It's no point in me talking about this to you when there are people who've actually been through this process who are going to comment on this. And I guess I'm just sort of flashing this up so that you've got an opportunity to go back and look at this. But I guess what you'll see here is that it's not just about the science. In fact, if you look at the majority of the comments, they're not just about the scientific outputs that have been achieved, but also about the support that they got, the fact that it was a really positive experience to go through, and the impacts that this has had on people's careers. And those are some of the key outputs that we're really looking for here. Okay, so it's not just about the opportunity for you to publish a paper, but it's about an opportunity for you to learn what it is to manage a research grant, how to pull together an idea and make a strong case, and then that sense of achievement that you'll get from delivering it as well in the long run. And clearly that's really important in the development of a future leading academic. Next slide, please. Okay, so I think I've whittled on for long enough about the general principles of the call and what sustain is. And I'm going to hand over to, I think in this order, Prof. Zishu Lee, Prof. Arnold Beckman, Prof. Mark Rainforth, and Prof. Claire Davis to talk about these different areas and to prompt some thinking around what the key knowledge areas might be within these relevant scientific challenges that underpin our grand challenges. So I think I'm going to hand over now to them to run through each one of those in turn. So Zishu first, thank you.
Hi, can you hear me okay?
Yes.
Okay, good. Thank you, Cameron. So I'm usually from the University of Warwick. So it's about this one. It's high temperature reaction and the kinetics, and the Cam has talked about loads of benefits to build this course. I'm going to really talk about the scientific aspect for the high temperature reaction and the kinetics. So the background is really the human beings have entered into the Iron Age about 3,000 or more than 3,300 years ago, I think the human being and the environment has been harmonized for a few thousand years, but only at the last 200-300 years, and the human being has done a lot of damage to the environment, particularly since the Industrial Revolution in Britain, probably 1750, I guess is that time. So now the environment has the human being has been penalized by these industrialized activities, and we have around 25 years to achieve the net zero. And the steel industry is one of the biggest emitter of the greenhouse gas emissions, and we need a lot of new ideas to decarbonize it to achieve net zero. So one of the important part is the new ideas from early career researchers. Next one, please. So in terms of this one, theme one, so we are looking for ideas between techniques ready level 0 to 2, ideally 0 to 1. So not ideas like already approved is new idea, has to be original, has to be a novelty. So what the original is K is basically what comes at is something you are fascinating with. You think you will bring some big changes, like step changes to the steel manufacturing. In the whole steel manufacturing is a high temperature process, and from so up to probably more than 2,000 degree in electric arc furnace, a normal blast furnace, DRI or EF steel making, the up to about 2,000 degree, normally probably 1,600 degree. So all this, so any process ideas for any of one of those process, I think meet the scope of this theme. So you could be doing something like about the slag, about HDRI, about the EF steel making, or downstream the high temperature process. And then your bid could be experimental, could be theoretical, could be simulation. You could including application of data science and artificial intelligence to improve to understand the high temperature process. That's also fine. I think that's all from me.
Hello, my name is Arnold Beckmann. I'm a professor of computer science at Swansea University, and I'm representing the digital side of Sustain. And today I'm presenting the Computational Modeling and Big Data Challenge. To give you a bit of context, there were various stages of industrial revolutions. The first one on mechanization, water power and steam power. The second, mass production, assembly lines, electricity. Industry 3.0 was the introduction of computer and automation into industrial processes. And you probably all have heard about Industry 4.0, the use of cyber-physical systems, so the use of computing and networking together with sensing within industrial processes. The new buzzword is Industry 5.0, and it is can be seen as a refinement of Industry 4.0, which puts the human into the center of anything which we try to develop in the context of Industry 4.0. I think that is very timely. You probably all are aware of the perceived threat which AI poses, rightly or wrongly, to the work environment. So the fear that it may replace the human at the workplace, etc., etc. And I think that is a reasonable and valid fear. So, and one needs to make sure that whatever AI we generate, it will be of benefit and not of threat to the society and humanity. I think it can be done if it's done in the right way. So in order to achieve those visions of Industry 4.0 and Industry 5.0, we need various forms of data analytics. And again, these come in stages and they have progressed over time. So originally we had descriptive and diagnostic analytics, which looked into the past in hindsight, trying to identify if something went wrong, why did it went wrong, for example. Yeah. Currently, we are more focused on predictive analytics. So trying to predict the immediate future, what will happen within the next steps. Yeah. So based on data, trying to predict these next steps. The goal, the aim is to get to prescriptive analytics, which goes beyond predicting the future outcomes by also suggesting actions to benefit from the predictions, and showing what the implications of these decisions are to the future. So in particular, prescriptive analytics needs some form of AI, in particular the capturing and use of human knowledge in these kind of decision processes. Now coming a bit closer to the challenge, so we industrial process, in particular steel industry, comes with particular data challenges. So industrial data in general, but in particular within steel, is heterogeneous. You have various data sources from legacy to modern equipment, various forms of sensors which are used, and other type of data which need to be integrated. Also, we have complex domain models which need to be taken into account. In particular, steel processes have a lot of models, mathematical models or other type of models which play a role in decision making. And in addition, there is rich background knowledge. So the knowledge, the human knowledge of the shop floor worker or the operator in making decisions, and that all needs to be taken into account. So therefore, the challenge focus is to use or produce advanced analytics approaches that leverage hybrid AI, so-called hybrid AI technologies, in the context of Sustain's grand challenge areas. So hybrid AI means a combination of AI technologies, and I'm mentioning here a rough delineation between statistical AI technologies such as machine learning and symbolic AI technologies such as rule-based systems or semantic technologies. The focus should be a combination of such methods and their potential for the steel sector. But if you have any other idea which combines AI technologies with industrial data from the steel sector, please talk to me. I'm open to anything which combines AI and data within the steel sector. Okay, that brings me to the end. Many thanks.
So you might have spotted there was no need for me to introduce Arnold because that was a recorded presentation, but we're very grateful for him for spending the time to do that. And next it's over to Mark, who is really here within the 4 digital walls. Thank you, Mark.
Hi, I'm Mark Rainforth. Next slide, please. So I'm going to talk about microstructure and monitoring microstructure. So I think we're familiar that microstructure is everything about properties of steel, but we have to span a lot of length scales. So, whoop, what's going on quickly? Can you go back that one? Thank you. So on the left there, you've got atomic image, and we know that segregation to grain boundaries affects properties, and yet we're making steel in hundreds of tons and using it at the order of 1 to 100 meters. So a huge length scale problem. Next one, please. So as I said, microstructure defines properties, and the microstructure is designed by processing. And of course, we know that steel is a complex mixture of phases, and that small changes in hot working or heat treatment and so on can have quite substantial changes in the properties. Next slide, please. So just illustrations there of steel making, typically 100, 200 tons, huge size length scale, then processing it, and changing that processing has a massive effect on the properties. Ideally, we would really want to be able to monitor the microstructure as we go through that process, to be able to, in real time, make changes to the microstructure. Next slide, please. Yeah, so here's another illustration of the same problem. So, for example, in the automotive industry, then the properties of steel have improved immeasurably over the last 10 years or more. The crash resistance, the weight of the body in white has gone down substantially. And that's all to do with improving the strength of steel. That is related to processing. So the image on the right there is nanoscale precipitation, which can have a dramatic effect on the strength of steels. So here, another example of roughly 10 to the 10 length scale issue. Next one, please. And that just shows this in a bit more detail. To really understand that precipitate structure, we've got to be literally at the atomic scale. So you've got atomic images on the right there, showing the interface between the precipitate and the matrix. That really does control the mechanical properties in a very big way. And being able to characterize the chemical properties at that scale needs atom probe. But we're just looking at a region of 10 nanometers or so there. Does that really affect the, is that really representative of 100 ton of steel that you're rolling? That is a massive challenge. Next slide, please. And of course, steels are usually complex mixtures of different phases. This is an example from a complex phase automotive steel. We've got pretty well everything there. So we've got a ferritic matrix, we've got martensite islands, we've got retained austenite, and we've got bainite there as well, and 1 or 2 carbides sitting around. It's a really complicated mixture. Quantifying that is just a nightmare, but we need to be able to quantify that to understand how the process affects the mechanical properties. Next one, please. Yeah, and segregation is again a major issue. So we've got a martensitic steel here. It's a Mar-aging type steel, immensely complicated structures, martensite and reverted austenite in this case. But the point is that the segregation, which I think is on the next slide, please, in this case a manganese along a grain boundary, which is just a few atom planes wide, really controls the way that we get the reversion to austenite during heat treatment, which completely controls the mechanical properties. So these small changes can have quite a dramatic effect on properties. Next slide, please. And this is just another example from a super 13 chrome steel. Very similar microstructure to the Mar-aging steel. But again, if you see the graph on the right there, this is plotting retained austenite content versus tempering the temperature. And you notice that the changes are very substantial over very small differences in temperature. So 5 degrees can mean a big difference between whether something is meeting the mechanical property specification and not. So understanding those mechanisms and being able to quantify and characterize the microstructure is really crucial. Next slide, please. And of course, we all have heterogeneities within the microstructure when we're looking at mesoscale structures. And this is a sort of scale that we would be hoping to see with online monitoring. So this is a rather nice example from various different steels where it's fairly homogeneous. We'll go to the next slide. No, next one. We've gone back. One more, please. That one, yeah. So this is showing some real heterogeneities in a normally processed steel. Scale bar there is 1 millimeter. So it's an EBSD map showing the range of grain sizes that you might see. Some of the austenite here has been conditioned to fine grains, others remains quite coarse. If we look at the next slide, and the next one, please. Then in there, we can select small changes in the microstructure and try and quantify this difference, pretty much visible to the eye, but quantifying that is a major challenge. But it certainly has a massive effect on the mechanical properties that we have. Next slide, please. So as we drive for high performance steels, we need to be able to fully quantify the microstructure with the tighter specifications and so forth. Monitoring is increasingly important. And we really need to be able to quantify these things across the length scale. So that is a challenge. I think that's it. Thank you.
Thank you, Mark. And last but by absolutely no means least, some more inspiration from Claire.
Thank you very much. So in this particular challenge, we're looking at some of the rules that underpin microstructural development. So we've just heard all about different microstructures and the importance of being able to quantify them because they have such influence on properties. Well, we also have rules in which the microstructures are developed, the properties are developed, and how that is linked through with composition and processing. So there is quite a bit of overlap here, but in this particular challenge, we're looking at the development and improvement of those rules, both through experimental design, but also modeling techniques. So what we're particularly wanting people to focus on here is how do we improve some of the models and rules that are available and extend it, for example, to those very complex steels that Mark was just talking about. Or maybe we want to apply them more to customer specifications. So, for example, crystal plasticity for forming approaches if we want to go for complex shapes. And how do we start to bring in the complex materials characteristics that affect the mechanical engineering forming behaviors. So we don't simply need to know about tensile tests and uniaxial strain conditions, but maybe taking into account the triaxiality of strain conditions and how would we ensure that we have the right materials information that would then allow customers, the final users, to minimize part rejection, for example. And there are lots of different ways in which this can be achieved. We mentioned here very much that it could be experimental approaches to understand these complex materials more, and how do we build up those rules on the links between those characterization of microstructural features and properties. So Cam mentioned about access to lab facilities. Absolutely, both within whichever university, if you're applying, you might be, but also access to the wider sustained network. So please come and talk to us. If you think you'd like to do some experimental trials, but you don't necessarily have the facilities yourselves, same with characterization, of course, then talk to us because we have a wealth of facilities and experience in using those facilities and experience on how the processing links directly to industrial processing, not just doing it in the lab scale, but lab scale that represents industrial process. So, we're very keen to see greater use of experimental approaches to provide quality data to allow these rules to be developed. But equally, it might be through the modeling approaches, anything down to the atomistic approach. We were hearing a bit about segregation behaviors and the importance of what is at the atomistic level, just a few atoms thick on boundaries. But how do we predict that? So, if your area of interest is on that level of fundamental modeling, fantastic. We're looking to see how these rules and models are future developed. Again, you can talk to us. Do we have data that might help validate your models? Because in an ECR project, you might not be able to do everything. You can't model, experimentally verify, do everything within a relatively short time frame. Come and use the expertise or the data that we've got. We're happy to support those kinds of activities as well. Next slide, please. So from perspective here, it's really about identification of what it is that, or what rules or what particular models, processing routes, etc. you want to be focused on, which may be directly linked to work we're doing now, or we really like to see sometimes where people who've been working in a particular area but want to take that knowledge and then apply it to something in the steel sector. We've had some interesting discussions with researchers who work in very different areas, but suddenly see analogous situations within the steel sector that could be developed further with the application of knowledge. We certainly really want to see that, for example, in some of the AI and machine learning approaches, because we know there's so much we can learn from where this is being applied elsewhere. Really important is to identify the current state of the art. And again, please come and talk to us if you're not sure. And then it's about what is that extension that can be achieved. And it doesn't have to be huge. You know, steels have been around for so long. We have actually got a lot of really, really good models, but they're not all comprehensive. And so actually, you know, for us, it's not necessarily massive step changes. You know, that's great if that comes along. We're also looking at incremental improvement, because when you're making millions of tons of the stuff, a small incremental improvement can be a huge benefit to the steel sector. So please don't be worried about saying, well, is this really big enough? Talk to us. And then it's about defining, you know, what actually is done. And we can certainly help with what's the additional benefits. You know, what would be the key outcomes and the impacts that, you know, you tell us what you want to achieve. And we know the steel sector. So we're happy to sort of say, well, actually, maybe you'd like to talk to X, Y, and Z, because they could really benefit from the work that we're doing. So I think for me, this is all about identifying what you want to do, talking to us, ideally, you come forward with ideas. It crosses over some of the other challenges that we have, not a problem. You know, there's no reason why you shouldn't talk to many of us. It's not about, you don't have to fit in just one challenge, fit across challenges. We're quite happy with that. And hopefully we'll have good ideas that we can then support. Thank you.
Should stop muting myself. Thank you very much, Claire. That's fantastic. So hopefully that's provided some inspiration in terms of areas that you could work on and sort of aligning to the objectives of the programme. I'm going to pass over back to Sarah now to talk about some stuff that I'm sure that you're very interested in, which is how you can apply, what the eligibility is, what the process is, and all of that sort of stuff. Sarah.
Thank you. Right, so we have a list there of a bit of information. So we have 3 awards available at the moment, 50k per award. This is at 80% FEC, so your university will provide the 20% on top of that, which is usual practice. For eligibility, it's open to all early career research UK academics across all UK institutions, so outside Sustain as well. And if you have been awarded previously and you're able to want to apply for another ECR, this is possible, but it has to be in a completely different area to what you researched before. Next slide, please. So the process, so the call opens today, and here we all are, that's great. We have surgery sessions lined up starting from the 7th of October. You can have a 20-minute one-to-one session with any of our scientific leads that you've just seen there, any of our mentors, which will be talking next. You can talk to me about your financial bits as well, if you have any questions. And we have 2 sessions, 2 days available where Cameron can talk to you as well on a one-to-one if you have anything you'd like to discuss with him. And that's on the 10th of October and the 25th of October. So as it says on there, if you get in touch with the info.sustainsteel email, just drop us a mail to say what you'd like, and we'll arrange that to happen for you. So you can see there, you can actually apply directly without speaking to any of our leads, but we do strongly recommend that you engage as much as possible with any of our mentors and scientific leads before you actually apply, because you'd be surprised. Sometimes you don't know everything, and so that's a really good reason to do that. Right, so submit application. So our actual deadline for you to get your application into Sustain via that same email address is 9 AM on the 4th of November. The team then picks up everything, and there's a massive amount of work behind the scenes where we will have a pre-arranged panel of experts outside of Sustain, so it's non-biased. They will be checking all the applications, and then we'll get back to you with all the outcomes and feedback given by probably the end of January next year. Next slide, please. So there we have all of our surgery sessions mapped out for you there. Have a quick look at those to see who you'd like to speak to. And I think now I actually hand over to Becky, who will introduce our development champions.
Brilliant, thank you, Sarah. So yes, we're fortunate enough, as both Cam and Sarah mentioned earlier, to have some of our previous successful applicants on the call with us today. So they have been invited to be part of this call to share their experiences with anyone who's thinking about going through a similar process, to help guide anyone who's interested through some of the steps that are involved in our ECR application. There will be surgery sessions with our ECR champions as well, and that previous slide that Sarah showed, we will be circulating afterwards, and it will be available on the website. So don't worry about if you didn't get to see exactly who you wanted to speak to on there. So they will be available to have surgery sessions with as well, to offer one-to-one support, and also to highlight the benefits of the call process for everyone who applies. So the process is designed to introduce people who haven't been through a funding process before, to understand what's involved in that, and to get some experience. So I think I can see you all on the call here. So I think I'll stop sharing actually, so that everyone can see everyone else. So Frank, I can see you there. I think Peng and Stephen are also here as well. So thank you very much for joining us this morning. We just wanted to kind of almost have a little bit of a mini panel session, really, to get you all to share your experiences. So I've got a couple of questions prepared, but if anyone who's listening has got any questions, do put them in the chat. And after the ECR panel, we will be opening up the floor to questions for all the scientific leads as well. So get thinking, or you can unmute later on if you have any questions. So the first one I've got on the list is basically a little bit, how did you find the ECR process, and what has applying for this funding kind of allowed you to go on to do? And I don't know if anyone wants to start on that one. Frank, you're unmuted, so I'm going to jump on you over there if that's okay. I can't hear you. I don't know if anyone else can.
I can't hear Frank at the moment. Perhaps while Frank is sorting his... I
was just about to say that Frank will come back to you in a second.
Or Stephen to jump in maybe.
Stephen, I can see you on the screen, so are you okay to have a go at that one?
Yeah, that's fine. Hi everyone. So in terms of how I found the process, I think there's probably 3 key points I'd make around that. So the first one is relatively stressful, in the fact that it was the first proposal that I'd put together and was trying to emulate leading a proposal as PI. So naturally out of comfort zone. But then as the second point to back up with that, I think engage, as you've said throughout the webinar today, actually engaging with the team, both the academics championing the specific areas, but also the sustained support team, asked them questions. They're always really helpful and came back with everything. So as much as possible, I think it's the most supportive environment that could be made to apply for your first ever funding call. And then I think you also said where we've sort of gone afterwards. I was really fortunate in terms of I was able to apply for another ECR call with the TFI Network Plus to continue building the project that I had at that time. And then really the most valuable thing that came out of it was all the industrial contacts and academic support and understanding of how to write proposals that came from that. So it's, yeah, very much helped me in my new role now as an academic at Coventry, having that network to pull on and support me and hopefully give something back to as well in future funding proposals.
Super, thank you, Stephen. Frank, can we see if you're...
I don't know whether you can hear me now.
No, we got you now.
Oh, great. Okay. Yeah, I really enjoyed this process. So when I was applying for the first round of the ECR, this is literally the first PI project that I was applying for. And I think one of the very unique feature of this is it has been designed so that it's not a big amount of money, but it's really representing the different stages that you go through as a PI applying for grants. So what I find particularly useful is the fact that you can talk to people. So in the future, when you applying for a bigger grant, maybe you're just preparing that with your partner, and then you submit it and wait for the decision. Whereas here you got, so many academics and mentor and the Sustain Center itself who are very willing and passionate in helping people like you and me. So I think really utilize that possibility of talking to people and getting the support as much as you can, because you will realize how much you get to learn through this process.
Brilliant, thank you, Frank. Peng, I can see you're online as well. Is there anything you'd like to add to what Stephen and Frank have said there?
Hello, Becky. Can you hear me now?
Yes, we can hear you.
That's great. Thank you, Frank and Steve, to share their experience. And I have the same experience with them as well. During the sustain, gave me the opportunity to talk with a variety of people from the different research area. And for me, especially that previously I focused only on my own research. And this ECR code gave me the opportunity to communicate with the industries and dig out their challenge or issues and help me to develop my own idea and own research area that I can go further to apply for my future grants. And for example, my EPSRC fellowship, which also based on my ECR program. And through this ECR project, I built my connection with industries. And I also have my research area to link with academics. And this all helped me to obtain my first grant funding. So if any earlier researcher want to develop their career in the future, in my opinion, ECR code will be help you to be not only the independent research, but also learn how to build up the future funding application skills and have experience to collaboration with industry, academia, and your collaborators. So that's all my experience through the ECR code. I learned through this ECR code. And thank you, Becky.
Brilliant, thank you, Peng. And it's really interesting that you mentioned industry as well, because there's a question that we've had in about, is it suggested to collaborate with an industrial partner when applying for the ECR? And this ties in with one of the questions I had about how did you go about engaging with industry and getting letters of support, and any advice you'd give. So is there any advice for kind of engaging and collaborating with industrial partners that you'd be happy to share? Yeah, go for it, Peng.
Yeah. My experience is industry care about the questions and may focus on the applications, which you may need to find out how to use your knowledge to give them the answer or help them to solve their issues. So they always have a gap, and this gap always give us the skills to improve our knowledge and collaboration pathway. So that's one of my experience through this ECR code to learn how to connect with industries. And I'm sure Frank and Steve have more experience than me, so maybe let them to share some experience.
Should I go first, Steve? Yeah. I think in terms of getting letters of support from industry, don't take it as a pressure, or this is a task that you have to do in order to get the grant. Having the industrial support means that you have naturally a pathway to make an impact. So if you're passionate about your research and you don't know who to speak to in the industry, then talk to one of us, because we would know who would be interested in this kind of area. And the support itself could be just, providing in kind, or it could be through discussion with industrial partners. And it's a wonderful thing, because you know that your research is then really interesting, and people are interested in that. And so I don't think it's a requirement that you have to have it, but it's very nice to have it. And if you don't know how to get one, then talk to one of us. We will put the right people in touch.
Thanks, Frank. Stephen, anything you wanna add to that one?
Yeah, I guess one thing I'd say is if you do intend to or want to collaborate with industry, my first suggestion recommendation would be contact them very early in the process. So as soon as you've got a rough idea, don't be scared to reach out. Everybody's nice and friendly, or you won't be given contacts of people that aren't. And it allows you, depending on the company or the industry, it can take quite a long time. It doesn't mean they're not interested, but it can take quite a long time to get letters of support signed off and things. So don't underestimate when you need to make that contact. And then the other thing I'd say is, in terms of like, do you have to include industry? I'd echo Frank's points of pathway to impact, but I'd say the other thing for me is, if your area of topic does align with something that is relevant to an industrial partner, or whether it's even at a very low TRL, why would you not involve industry? Because realistically, in those processing roles, or even in the R&D roles, there tends to be people that are even more specific and focused on particular research areas that you might be crossing over with. They have more time to work on that specific problem than maybe academic partners do. So it's actually a way of getting additional access to people with more expertise and knowledge in the area that you might be looking to research. So I wouldn't underestimate or undervalue what industrial contacts bring from that core knowledge perspective as well.
Brilliant. Thank you, Stephen. Thank you, Frank and Peng, as well. That's been really, really interesting. I think we've got just under 10 minutes left, so we are going to open up the Q&A now to the scientific leads as well. I think our ECR champions are going to stay on as well if there's any further questions. Cam, I didn't know if you wanted to add to the industrial partners point before because there's no questions in there at the moment. If anyone wants to raise a hand or put anything in the chat, do it while we're still talking. But yeah, Cam, I didn't know if you wanted to add to that one.
Yeah, I mean, I like Stephen's point about the fact that we're not going to introduce you to anybody who's horrible. I mean, so have some faith in that process. It seems to have worked so far. And you know, the access through the hub in terms of with industrial partners brings with it the culture that we're trying to foster and the values that I discussed earlier on as well, about being collaborative and open and supportive. And I think that's something that's really shone through, not just the academic collaborators in the SUSTAIN program, but also the industrial collaborators as well. So, I mean, everybody that you would speak to, at least via us, for sure, you know, is going to be bought into that ethos of trying to support you to develop the best application possible. But I don't think I can say anything that's more insightful than what we got from Frank, Stephen, and Peng, to be honest, because those were excellent comments and better than I can come up with. So they've walked the walk, after all.
I think the long and short is highly suggested that you get collaboration from industrial.
Yes. Yeah. Are there any questions coming in now? Because if there's not, there was one other point that I just wanted to raise. Becky?
I can't see any others at the moment, but I was going to say, do put hands up, but things in the chat.
Please do, or just shout me down, you know, it's often required. So the other point was just around eligibility. So just to make it super clear, what we're trying to do here is create opportunities for people that would otherwise not have those opportunities, right? So with regards to eligibility, it's important to realize that we want to fund people who are not eligible to receive or normally to apply for EPSRC funding outside of extremely competitive fellowship opportunities. And even those are quite hard to gain institutional support for. So this is really for researchers who might be working on contracts as part of wider programs and things like that, who maybe either be coming to the end, or even if you're not coming to the end of your contract, then we're willing to try and discuss, you know, with your PIs, how we might be able to facilitate you to apply for the school and carry out the research as well. So it's really about providing those people with the opportunity to apply for funding. So if you are already eligible by virtue of, say, for example, holding a permanent academic position of applying for funding, then this is, whilst we appreciate that you're still at a very early career stage, you have an opportunity that many others don't, and we're trying to fill that gap with this call. So I think that was quite an important part to make. But then that, I think, opportunity is the one that Frank, Stephen and Peng were talking about. I think they all said it was their first opportunity to have a go at doing something like this, and that's because these opportunities where for researchers rather than permanent academic staff members are very few and far between. So just wanted to make it clear that's what we're focusing on.
Cool. Ellie has put the link to the page on our website in the chat. There's lots of information on there. And in a few days' time, we'll add the recording and the slides from this webinar on there as well. I've just put the surgery sessions back on screen briefly, but again, we will make sure these are on the website in the next couple of days. And do get in touch with us via the email if you'd like to book one of them, or if you can't make any of the times, do let us know as well, and we'll see if we can arrange something else. But these are our time slots that are in people's diaries. So yeah, do let us know. I can't see, are there any questions, any hands, anything in the chat? I can't see anything at the moment.
Always good to go for a nice, long, uncomfortable Zoom pause, just to see if we can weed out a question or two.
Okay, while people are thinking, then I've got one more question. If Frank, Stephen, and Pang are still here, other than what you've already said, is there any other advice you'd give to anyone thinking about applying? Anything else that you wish you'd have known at the beginning of the process, or anything like that?
The one thing that I realized is I thought that the research that I'm doing is so different than the support that I can get. So I don't know who to speak to, but actually I think we are all working in the science and engineering area, and we're just so interested to know more, isn't it? And we're happy to pass on to the right person, but we are also very passionate about learning new stuff. So don't be afraid that what you're doing is different than what we do, and then worry about it.
Good advice.
Yeah, I think the only thing I'd add is, as it's your first, probably your first like proposal being ECRs, is also take the opportunity and talk to your internal funding support teams very early on. From my experience, they are different at different universities and the processes you have to go through, and some of them bring more hoops to jump through than others. So yeah, find whoever you kind of work with already that is eligible, get them to put you in contact with the right person who can talk you through the journey and the deadlines you're going to need to meet internally, because they might not match up with necessarily the program deadlines from Sustain's perspective.
For my on my side, my advice will be to discuss with your lab manager, or maybe who has the similar research background with you, to discuss on how to get the good proposal writing, because this is one of the skills may be important for your future career development, because we all need to write a good paper or good proposal, and this is one of the skills we can practice through the ECR call, and learn and share your proposal to senior researchers or academics to collect their advice, and this will improve your writing skills. And that's one of my advice learned from my ECR call.
Thank you, Pang, and thank you to all of you who've contributed to this webinar, and thank you for those of you who've arrived. We can't wait for you to join the partnership. We're really geared up and super excited to support you in developing excellent proposals, and the more successful you are, the more successful we are. So together, I'm really hoping that we can do some stuff that will change both your careers, but also add significant benefits and quality to the Sustain programme. So thank you very much, everybody, for your contributions and for coming along, and we'll speak to you all soon.